All right, so let's get started here. Anybody want to lead us in prayer before we go into the fun stuff? No volunteers? I'm offended. All right, I'll lead us in prayer. Father, we thank you for bringing us together another blessed and beautiful day uh, to conquer our fears, to grow in wisdom and discernment. And we just thank you for continuing to do what you're doing with us and giving us the freedom to speak your words, even in a subject like math. We can talk and share the word and just be free to grow as you would have us to grow, Father. And we thank you for leading us where you're leading us right now. And all the wonderful plans you have for us. And we ask that you make us a part of your plans, whatever those are, wherever you'll lead us, Father. In the name of your Son, Yeshua. Amen. All right. So now we're going to go with, we're going back to equations. And I know for some of you, you're like, this is too easy. This is review. Trust me, it's going to get way harder and you're going to be lost within the next few weeks. I'm just kidding. No, it's not gonna be too bad. But I do want to make sure we understand this before we go into the quadratic equations and things that are a little more tricky. So we're going to look at uh, a kind of a way to solve any equation, even when it has 4 steps, 5 steps, whatever the equation is. I've got a way, a guide to do that, and I didn't want to hit you guys with that last week right off the bat. It's a little bit much, but the first thing I want to look at is equations that have variables on both sides of the equation. So, like we would have our 3x on the left, and we got that 2x on the right. A lot of times that throws people. This has a laser pointer. What does that do? Oh, it like, oh, okay, sorry. I was curious what that did. I guess it doesn't do what I thought it would. But so what I want to do is if I have a variable on both sides, I want to get the variable to one side of my equation. So before we solve an equation, like when we get a final answer, it'll say x equals something, and there will be a variable on one side. So if you have a variable on both, what you want to do is move the smaller one. It technically doesn't matter. You could move either one, but it makes it one step less if you move the smaller one first. So when I look at those two variables, the 2x on the right is smaller than 3x on the left. So I'm going to subtract that. And all that does is it keeps the variable positive. So when I'm doing this, I'll subtract the 2. That way on the left side, I have a positive x. Um, in my equation, I'll just bring the rest of that down. Everything else that I didn't get rid of just drops down. And I wanted to kind of go back and touch base on this because as we move into difficult equations, you're going to want to know how do I get the variable to the other side. So we'll just subtract the smaller one. Always start with the smaller variable, subtract it over, and then it becomes a one-step equation from that point. And you would just do the opposite operations like we were doing last week, um, solving. So anytime you see an equation that has two variables and one's on one side, one's on the other, just identify the smaller one, whatever that one is, and I'd subtract it to move it over. So equations with variables on both sides are pretty easy. You just want to move the smaller one. That way you don't have to get rid of a negative when you get to the end of that equation. It'll save you that extra step. It'll keep you from getting the wrong sign in your answer. So when you do these equations, you just subtract and make sure you subtract it from both sides. Move it over. Uh, and then your equation becomes a two-step equation from there. And when we talked about last week solving these equations, make sure you follow the steps. I'm not going to solve this one out, but I would take care of the subtract first before I divide by 4 because order of operation, when we solve equations, the order of operations is backwards. And that's more of like an eighth grade thing. Y'all learned that last year, I'm sure, if you had a teacher as great as mine. Uh, So anytime we see those variables on both sides, subtract the smaller one, whatever that is. And that is, hold on, sorry, I'm skipping those. Some of those examples, y'all don't really need those. But I came up with a list of steps. And there are 4 steps on this list, and I don't know if we got this far last time. When we get into equations that have 4 or 5 steps, this list of steps, you may not need all of them, but if you follow this order, you cannot mess up. So if I'm looking at an equation, the first thing I'm going to check for is there something to distribute? So in this equation, I'll go to step one, and yes, there is something that I have to distribute, and I will take care of that first. And this list of steps will help you out in solving any equation. And I'll distribute 2 times x is 2x, 2 times 3 is 6. And I'll go to that list once I'm done working this out here. And I'll say, all right, combine like terms. That's my next step to look for. There may not be like terms to combine, but when we say combine like terms, we're talking about anything on the same side of that equation. So like on the left side, I've got 2x plus 6 plus 4. Out of those three terms over there, the 6 and the 4, those are just whole numbers. Those would be what we call like terms. You can add those together. So this would give me 2x plus 10. I can't add the 2x and the 10 because they're not like terms, but I will look and see if there is anything that I can add on the same side of the equation. Uh, Now in this equation, step number 3 doesn't matter. I don't need that step because the variable is only on the left side. So you may not need all 4 steps, but it's a guide to kind of show me what steps could be there. And then step 4 would be solve that equation. It's a 2-step equation from now this point. So it's pretty easy. I would do add or subtract first, and then I would go to that last step right there where it is uh, divide or multiply. And that would be our last step. So we're following that list of steps, and that will help us solve pretty much any equation that we're going to see in Algebra 1. Um, it would actually help us with probably any equation, I'm sure. But those are the list of steps that you would follow to solve an equation. And I wanted to give you guys an example of something that has actually all 4 of these steps. Okay, so this equation actually has every possible step that we're going to be looking at. So step one, distribute. That's the first thing I'm going to look for. If it's there, it's there. If not, we don't worry about it. But there is something to distribute out here. So I would multiply that out and bring down everything else. So just do these, when these equations look really crazy, just do them one step at a time. So I'm going to take the 2, multiply that out, bring down anything else that's left over. So I still have the plus 4, still have the 3x, and I still have the plus 10 over here. So we'll do it one step at a time. So we distributed, and now I'm going to look for combining like terms. And on the left, there is a 3 and a 4 that are able to be added together. So I can't do anything with the 2x because it's not a like term with 7, so I can't add those together, but I could add the 3 and the 4. And then I bring down everything else. And you'll notice this equation gets smaller as we go kind of down the page here. And then the next step, get the variable to one side. Just depends on which one's smaller, which way I'm going to go. When you get your equation solved, it doesn't matter if it's x on the left or x on the right. It really doesn't matter. So I'm just looking at 2x and 3x, and 2x is the smaller variable. So that's the one I'm going to subtract to get it out of my equation. And from there, now my equation only has 7 equals, and 3x minus 2x is just 1x. We won't put a 1 in front of it because it's understood in algebra that that's just a 1. That's just 1x. If there's more than 1, you'll see the numbers in front. But that makes it a one-step equation. And in this case, all I had to do was that last step, add or subtract. I would just subtract the 4, and that would tell me that x equals 3. So that is as many steps as we're going to be dealing with this year. We'll be following those 4 steps, and that will be kind of our guide as we go through these really difficult equations. We're just going to make them easy. It's always a one-step equation. No matter how many things there is to do, it's just one step at a time. As long as we keep it that simple and we can once you get to practicing this, you'll kind of remember what to do and you won't need that list anymore. But it always helps to kind of have that on this off to the side, kind of as a guide, so you know, make sure you're following the correct order. Because equations are just about following the correct order for whatever steps we're trying to do. So if we follow our steps, step one, distribute this 4. That's going to give us 4a plus 8. And then all we're doing was that first step. We'll bring everything else down exactly how it is. That A got really small on the other one. So that's step one. And then we'll go to step two, which is combine like terms. So that is something we need to do because on the left side of that equation, we have 4a and we have a. It's like adding apples to apples. Those are like terms. 4a plus a is 5a. And then and we're just doing that one step. I combine the like terms. On the right-hand side, 3a plus 14, they're not like, so I'm not going to worry about those. But I'll bring down everything else, and then I'll bring down 3a plus 14. And that leaves us with that third step. Get the variable to one side, and we actually need to do that. So I would have to move the smaller one, 3a, that'd be the smaller variable. So I would move that over, and then I would go on to the next step. So subtract that, 2a, 5a minus 3a is 2a plus 8 equals 14. And now it's a two-step equation, and it would just be a matter of following those steps in reverse. I would add or subtract first by subtracting 8 from both sides, and that's going to give me 2a equals 6. And then our last step, divide or multiply. I would divide by 2. That gives us a equals 3. Was everybody able to get that? If you're lost or need any explanation, don't be afraid to yell at me. Or if you fall asleep, let me know. I'll wake you up. All right, let's try one. I'd erase that without asking if anybody still needed to see that. That was rude. I apologize. Okay, so let's try one more of those. I'm gonna leave that list where you can see it. Yeah, and this list of steps, we came up with this when I was teaching in Dalton High School in North Georgia. We're trying to come up with a way that would help everybody solve an equation no matter what. And these 4 steps actually really do a pretty good job. I don't know how we survived equations before that. And when if somebody finishes and they think they got it, if you want to show us how you did it or talk us through it. Or is that too many steps? You guys are the quietest class I've ever taught in my life. I'm used to teaching middle schoolers. They're not very quiet after lunch. They're very skibbity. Anybody think
I
they
don't
got
really
it yet?
understand it.
Don't really understand it? Who said that? I heard a
Um,
voice. I heard a voice.
I
Was
don't
that
really
the Higley
understand it.
girls? Oh,
Yeah, sir.
okay. Okay, don't understand it. All right, so what do you think the first thing would be to do?
No, no.
So if you look at that list right here, distribute. Do you see anything down, like distribute would be like, anything next to parentheses. So like in the equation, you see 2 times 2p plus 1. Uh-oh. So anything to distribute, that means like, do I have something outside of a parentheses that I can multiply in? So there's a 2 right here next to the parentheses. So that tells me that I will actually have to do that first step. So the first step is look for anything that's outside of a parentheses, and I will just multiply this, 2 times 2p, and that would give me 4p.
Look at it.
And then 2 gets distributed to everything in that parentheses right there. So now 2 times 1
We're not
is
on.
positive 2. So I just take care of that first step. So look for anytime you see a number outside of the parentheses, that tells me I'm going to need that first step right there. And once you've taken care of the distribute part, just bring down everything else in this equation. So in my equation, I still have the 6 that hasn't been messed with, and I still have on that right-hand side 3p plus 11. So I've only done one thing. I just multiplied that 2 by both of those terms inside the parentheses. And then I bring down everything that's not been touched. So I've done one step so far out of the 4. And now I'm going to look at step number 2 where it says combine like terms. And that just means like whole numbers to whole numbers or variables to variables. So that's my second step. And if I look at the left side of this equation, I've got 6 plus 4p plus 2. Out of those three terms, the whole number 6 and the whole number 2, those don't have variables. So I can add 6 and 2 because those are just numbers. But 4p is not a like term with 6 and 2. So those can't be added. So when we talk about combining like terms, that's like adding apples to apples. I could only add numbers to numbers. And if I was going to add 4p to something, it would have to have the same variable. So 6 and 2, when it says combine like terms, I'm just adding those together to get 8. And then so that was that second step. I added those two numbers that could be added. On the right-hand side, 3p plus 11, those are not like terms. So when it says combine like terms, these two over here are not like. So I really can't add those together. The only two numbers that can be added on the same side are the 6 and the 2. And now I can just bring down everything else that we haven't touched. And I'll bring down everything else here. And I'll look at my steps again and say, okay, is the variable on only one side of this? And if we look at that step, get the variable to one side, do we have a variable on both sides of that equation?
Mm-hmm.
Right? We have a 4p on the left and 3p on the right. So I'm going to move it to the other side, and I'm going to ask myself, which one of those is smaller, 4p or 3p? And I would take the smaller one. So since the 3p is smaller and it's positive, that's why I'm subtracting this. So it's a positive 3p. I'm going to subtract that because I want to move it to the other side of my equation. And I'm trying to get this variable all by itself. So since it was split apart, I had to subtract it from one side to move it to the other. And once you have subtracted it from both sides, it's now canceled on the right. And my left side of the equation here is just bring down the 8. And I've got 4 minus 3p is just p because there's only one p left over. And then on the right-hand side, we've gotten rid of everything except for the number 11. So now this becomes a one-step equation where I'm just going to look at that very last step is order of operation is in reverse. And the only thing to do here is add or subtract because there's only an 8 plus p. So I would just subtract 8 from both sides. And that would give me p equals 3. Does that make a little more sense or no?
Yes, sir, it does.
Okay. Uh, yeah, sometimes it's just a matter of like slowing it down or
Thank you.
breaking it down. My college professor talked so fast I failed my first year of math in college and my first year of math in high school. It was like and she'd go so fast that by the time she was done, I was still trying to write down the first step. And she'd be like, "Any questions?" And I'm thinking, I don't even know what I would ask other than what are you doing? And they would like before we would take a test, they would like make you they made you feel like you were in prison. They would put you behind this glass window room where they were watching you and they would like check your calculator, check your pockets. I was like, man, how bad is cheating at this college that they like search you for stuff and they're like, okay, now test. And they'd be watching you the whole time and you're like, I'd be nervous that I was just being watched. I wasn't even trying to cheat. But one thing I didn't like though is they would count an answer wrong if you didn't show all the work. Like I ran out of space and I had to start and erase where I had worked out and keep going. They counted it wrong and I was like, I got the answer right. They're like, yeah, but you didn't show all the work. I was like, oh my God, you watched me from a glass window. You know I wasn't cheating.
That makes more sense. Thank you.
Oh, you're welcome. So there's another one we can do this one for of our last example. Let me see what time we are at. 5:30. Yeah, it's getting late. It's past your bedtime. Sorry, guys. It's 5:30 here anyways. So yeah, if we go back and let me bring the steps down here. I lost my steps. Where are you? I need my select. Go here. Maybe I can copy it. Am I still on pencil? Oh, I didn't click it. There we go. That's why. I'm having trouble with copy and paste. There it is. It would not let me copy and paste stuff earlier, and I don't know why it does that to me. I'm gonna crop this so that 16 is not getting in our way. Because it doesn't matter what number we're on. We can do whatever number we want. Didn't mean to delete that. Okay, there we go. So I have my list of steps over here, and I have my equation, and I'm going to go through one step at a time. So I'm going to look at the first step. Did we already do this question? Was that the last question we did? Oh yeah, that was the last one we did. Never mind. We did
Yeah.
that one. That's the same one. I was about to do the same problem. I thought that was the last problem, but it wasn't. That was the last problem. Okay, well, never mind. All right. So I was gonna give you guys some practice problems to do on that. I'll just put them on our class page so that you have some equations to work out that have all those steps on them. And that's as far as we're going to go with equations. But I did want to show you one thing first before we get into our review games here. Sometimes you'll see an equation, and I came up with an example. Where'd I put it? Um, where there's a fraction in your equation, and this is the kind of equation I think that a lot of people have trouble with because they see something happening up here, and they see a number down here, and they see something like this. So if you ever have an equation with a fraction in it, the first thing you're going to want to do is look at the top of that equation or that fraction, how it's got the two numbers in it. Those two numbers, like when we're solving an equation, we always say, oh, well, do I distribute? Do I combine like terms? Get the variable to one side, and then order of operation is in reverse. Well, this is a little bit tricky because x plus 10 in the top is being divided by 3. So a lot of people see this and they go, oh, order of operation is backwards. And then they try to subtract the 10 from both sides. But I can't really subtract the 10 because x plus 10, both of those numbers are being divided by 3. So they're kind of stuck in the numerator. So if you ever see an equation with a fraction, all I have to do to clear the fraction out and make it an easy equation is get rid of the divide by 3 because technically those two numbers up there are stuck together. They're both being divided by 3. So I can't just add 10 to both sides because that 10 is being divided out by a number. So what we'll do is if we ever see something like this, we will just multiply by whatever's in the denominator to get rid of it because multiplication cancels out division. They're opposites. So that would clear that fraction. Um, and it would leave me with just x plus 10 equals 12 times 3 would be 36. So you'll get these equations where you have something in the bottom of a fraction. You just get rid of that by multiplying, but don't try to add the number in the top. Like a lot of people see plus 10 and they try to subtract 10 from both sides, but it's kind of stuck in that numerator up there. So then I would just subtract the 10 here. All right. So I wanted to show you an example of that, what it looks like when there's a fraction.